In this video, we will be adding and subtracting polynomials. We'll start with terminology. A monomial is the product of numbers and/or variables with whole number exponents. So it's important that we think about monomials because monomials are what makes up polynomials, which is what we'll be adding. The degree of a monomial is the sum of the exponents of the variables in the monomial. A constant has a degree of 0. The terms of a polynomial are really monomial expressions separated by a plus or a minus sign. A polynomial with 2 terms is called a binomial. 3 terms is called a trinomial. The degree of a polynomial is the degree of the greatest degree term in the polynomial. The leading coefficient of a polynomial is the coefficient of the term with the greatest degree. And it's important to know we write polynomials in standard form, which is where the terms are ordered from greatest to least degree. So let's get practice finding the degree of monomials. What we want to do is pay attention to the exponents of the variables. We want to note that y is raised to the power of 1. We now add these exponents together. The degree of this monomial is 6. In the second example, we're looking at the exponents of the variables. The degree of this monomial is 4. In the last example, we want to ignore the exponent that is above the 12 because that exponent does not pertain to the degree. Only the exponents of variables pertain to the degree. So we want to add the 1 plus 3 plus 1. The degree is 5. So that's how we find the degree of monomials. Now to write polynomials in standard form, we have to pay attention to the degree. We want to write it so the greatest degree term comes first. So in the first example, it's going to be rewritten as n cubed plus 2n squared. And remember, there's a 1 understood to be multiplying that n cubed term. So the leading coefficient is 1. Now we look at our next example, and there are 3 terms. The term with the greatest degree is the 5x cubed y cubed z plus 8x y squared, and we always end with the constant term if there is one, minus 9. This is now in standard form. The leading coefficient is 5. So in the last example, we look over the 3 terms that are there and we put the term with the greatest degree first. It happens to have a negative sign with it. Make sure you keep that negative sign. Leading coefficient is negative 3. Now that we have that terminology and that important foundation down, let's get some practice adding polynomials, and we'll write our answer in standard form. So a very important thing about adding polynomials, if the polynomials that you're adding are not in standard form, you might want to rewrite them in standard form first. In this case, they already are in standard form. With adding, because there's no number in front of the parenthesis that I'm distributing, in this case, the parentheses serve no purpose, and we can drop them. So here's the addition sign, and my first polynomial, I'm just going to rewrite. My second polynomial, I'm going to rewrite. Now, one strategy that students like to do is to line up the expressions vertically and combine like terms. So notice that I put a 0x for the linear term in that second polynomial. The reason for that is because you want to make sure the constant term 7 is underneath the other constant term of 1. So we simply add these coefficients and we end up with our sum, which is in standard form. Negative 5x cubed plus 2x squared plus x plus 8. So we'll get practice adding polynomials, but using another strategy. And so it is suggested that you could rewrite the polynomial add-ins in standard form. remembering we don't need those parentheses. So here's my first addend, and here's my second. And the strategy we'll suggest is to work horizontally. And so simply combining like terms, my 2x cubed term comes down because there's nothing else to combine it with. The 3x squared term is the only quadratic term in this polynomial. And then we have minus 6x plus 8. And that is our final answer for adding those polynomials. All right, so let's take a peek at subtracting polynomials now. And the suggestion that we have for you is to ignore the parentheses of the first polynomial, put a -1 in front of the second one, remembering that we have to distribute that -1 to all three terms. So now we'll rewrite the second polynomial as adding the opposite of each term. Now we can line the expressions up vertically, and we can combine our like terms. Because notice, once you rewrite it as an addition problem, you're just adding polynomials, which is something that we probably feel more comfortable with. One more example for subtracting. In front of the second polynomial, remember we want a -1, which will be distributed 3 times over. And how I like to think of that is, I'm going to rewrite my first polynomial, but my second polynomial, I'm simply going to change the sign of all 3 terms. So I'm going to have -4x squared plus 5x minus 11. So I want to look for things I can combine here. My x squared terms, my x terms, and my number terms. And that's my final answer for this problem.